Hi, I'm Oluwakemi. I'm excited to have you here again. This is JAMB Physics 2017, which goes thus. The temperature of a gas of volume 60 centimeter cube is 42 degrees Celsius at a pressure of 400 millimeter mercury. Calculate the temperature when the volume is 90 centimeter cube at a pressure of 460 millimeter of mercury. So this brings us to the formula, the ideal gas equation, which is V1, the product of V1 P1 over T1 equals V2 P2 over T2. So we're going to see the values of all these. The V1 is the initial volume, which is 60 centimeter cube, okay, while the V2 is 90 as shown in the question. Then P1, maybe we'll just start imputing the value directly. Okay, so we have 60 times P1, which is 400 as given in the question. You can see the force pressure over the force temperature, which is given as 42 degrees. But what happened is we can't use degrees Celsius, so we need to convert that to Kelvin temperature. So we're going to add 273 to it to make it Kelvin temperature, which will be 314 Kelvin. So we're dividing this by 315. Okay, then the second volume as given in the question is 90 centimeter cube times the second pressure, which is given here as we can see 460 over the second temperature, which is what we are asked to calculate. Okay, so now we have T2 equals 315 times 90 times 460 to be divided by 60 times 400. Okay, let us quickly cancel out the zeros. Okay, so that is done. Then we can use the calculator. If we use the calculator now, let us use our calculator. All right, so we have 315, sorry about that, 315 times 9, then times 46. Okay, and this is to be divided by 60 times 4, that's 240. So we divide that by 240. We have 543.375 Kelvin. But we need to convert it back to degrees Celsius because that is exactly what we have as the options. So what is going to happen? Basically, we just minus 273 from it, and we have a final answer, which is 270.4 degrees Celsius. So this is our final answer. So the answer option B is the right answer. Thank you for watching. See you in the next video. Bye bye.